So good afternoon, everybody. It's great to see so many people. Standing room only for the passivhaus Superstars session. Give everybody a cheer. Excellent, thank you very much. And even people sitting on the rows in the middle. This is like the good old days as it used to be. I'm John Bootland. I'm the Chief Executive of the Passivhaus Trust. You're going to have to put up with me for about a minute, and then we're going to get straight into the meat of the presentations. These are the leading projects, the most famous projects that we've got for the passivhaus movement at the moment. All of them have been on TV or have won major prizes. There are many more that have also won prizes, but these are the selection we've brought with you today. And just as a quick thought, given the topic of eco-build, or the focus of future build this year on zero carbon and the answer to the climate emergency, I'm just going to show you a couple of slides that show you why we think that passivhaus is the answer to part of this climate emergency and the answer towards getting you towards zero carbon. But literally only 2 slides. So everything has changed in the last year. Everything has changed. The stories from Australia, the climate emergency declarations, over 200 councils have now declared climate emergency. And instead of, the Passivhaus Trust has been promoting Passivhaus in the UK for over 10 years now. Oh, sorry, this is our 10th year. This is our 10th year. And instead of us going out and actually trying to persuade people to think of Passivhaus as being an alternative, we're in a new way of working. In that local authorities are now phoning us and saying, we've declared a climate emergency, we've got to get to zero carbon, now what do we do? So it's been a complete change of emphasis for us over the last year. It's been fantastic to see so much interest, as you can see today. And the interesting question, I think, to think of is Passivhaus the route for achieving zero carbon? And on your seat, you should find a little booklet that explains about Passivhaus, the standards. So it's this one. And inside that, there's a little business card that takes you to a link to downloadable information about why Passivhaus is the only way to get you to zero carbon in reality at the moment. Other routes will become available, but at the moment it's the only way. We reduce demand first and then deal with supply to take you to the zero carbon point. Anyway, so you've got 3 speakers today. They're all going to talk about how Passivhaus gets you towards this point and why to do Passivhaus and how to do it well. The 3 projects we've got have been a Sterling Prize winner on Grand Designs and on George Clark's Building the Dream as well. So you can go and see the programs or go and find out much more information about all of the projects whenever you want. We're going to have 3 speakers, 20 minutes each. We'll do questions after each speaker so that you can ask them specifically about their scheme as well. And then we're going to finish at 1:45. So that's it from me. The speakers are all going to answer this question for you, hopefully. And I'm going to invite our first speaker up to come and join us, who is James Turner from Michael Riches, who's going to talk to us about Goldsmith Street, the Sterling Prize winning project.
Thanks, John. As I've just been introduced, my name's James. I'm from Michael Riches. I was the associate in charge of Goldsmith Street, which has been kind of said won the Sterling Prize this year. So this has been kind of awarded the UK's best building of 2019 by the RIBA. I think what this presentation tries to cover is what makes the scheme special, because actually in many ways it's a very ordinary scheme. I think a lot of people have kind of wondered why it's been put on a kind of pedestal as this kind of best building of 2019, and actually I think it's that kind of quietness that actually makes it special, and it's all the things that you don't see, which I'm going to touch on today, which makes it kind of hopefully an incredible project. We call this presentation Creating Buildings People Love, and I think that's what we're doing as a practice, is it's building homes, building communities, and I think one of the things that Goldsmith Street has done as a project is looked at kind of social housing in a new light and actually taking kind of sustainability kind of to this sort of level rather than just this kind of thing that everyone's doing because it makes them feel better. So given that I'm here kind of talking about Passivhaus today, it's been kind of recorded as the largest 100% social housing, 100% Passivhaus scheme in the UK. And this, this project's been on the books for nearly 10 years. I've been working on it for 5 years. There was a recession in between. And our client, Norwich City Council, has really kind of had to fight hard to keep this kind of mandate of wanting to deliver a passive house project, which is not easy. It's actually a very simple series of steps to actually make passive house work, but to actually get it through procurement, get it through kind of the complexities on site, that's been the real challenge. And that's where, I'd kind of hats off to our client for actually sticking with it, because, it's normally the first thing that gets chopped out through value engineering. And, I think what this project shows is it can be done, and it can be done by a local authority for a budget. So I'm just going to put the budget straight out there, because I'm sure that will be one of the questions. We built this scheme for $18.75 a square metre, which is a little bit higher than some people might say is a kind of reasonable build cost. This includes all of the site works, all of the landscaping that you're going to see in the photos, so the only thing that wasn't included is land cost and consultant fees. I think that's incredibly good value for the quality that we've achieved on site, and as I say, as we go through, I'll kind of touch on a few more things in the presentation. The key thing that I like to kind of communicate is that it's a completely normal design team setup. The only thing for a passive house project that you need is 2 additional consultants, and one is your passive house designer, the other is your passive house certifier. The certifier is a completely independent third party to the design team, and they basically report back to Germany to get your certification, and that is kind of almost your QA procedure of making sure that what you're getting, what you actually wanted. And also, passive house is something that we locked into the contract as a contractual obligation. The contract was a traditional JCT contract, so really trying to make sure that we actually got the client what they wanted, which was a passive house certified project, because too many projects kind of fall by the wayside by the end. Just to kind of rewind 10 years, so this was a project that the practice did in in Elmswell in Suffolk, called Clayfields. And this was kind of, at the time, kind of seen to be groundbreaking. It used a lot of very sustainable, low carbon materials. But what made it special was that it was kind of a solar scheme, we called it at the time. So not a passive house scheme, but a solar orientated scheme. And it kind of did the kind of classic magic arrows of kind of ventilation and sun path. But actually, there was some serious research that was done by Arabs post kind of occupation. And what that kind of taught us as a practice was that the solar aspect of the scheme, that free energy kind of capturing that free energy from the sun, really worked. And sort of, a few years later, that kind of knowledge was taken into Goldsmith Street as a kind of very simple premise of kind of orientating your buildings to capture free energy from the sun. So just kind of part of that capturing the free energy from the sun is making sure that buildings don't overshadow other buildings, thinking about the site plan, thinking about solar orientation. But also, this isn't just about kind of energy, this is about creating places people want to live. So one of the emphasis of this scheme was thinking about landscape, how landscape and the use of the car can be embodied in the scheme. Car usage is huge kind of carbon impact, and it's trying to create a neighbourhood where people didn't feel reliant on the car and it wasn't solely designed around the car. Just conscious of time. So another key aspect of the scheme, nothing to do with passive house, nothing to do with carbon, but actually creating places where small children can play and creating kind of viable neighbourhoods and communities. So on to Goldsmith Street. As it's been said, it's won numerous awards this last year, including the Sterling Prize, Housing Design Awards, Need Brown Award for Social Housing. I kind of feel slightly bashful kind of having to kind of present this, but I think what's incredible is it's really been noted that the kind of standard of social housing in this country can be lifted, and that local authorities delivering it to a much higher standard than some developers should be kind of promoted and encouraged. And also, I think from us as a practice, it's actually giving local authorities the confidence that it can be done, and it can be done, and it isn't this big risk that they need to take on. Just very quickly about the project. So for those of you who know Norwich, the site is to the west of the city centre. It's a 10-minute walk, so very easy to kind of walk into the town. And it's next to an area called the Golden Triangle. So it's street upon street of Victorian terrace housing, like you might find in any town or city in the UK. Very familiar, very simple. And one of the things that we observed at the competition stage was that those terrace houses were 14 metres apart. Most planning authorities encourage a 21-metre overlooking distance. So we've kind of squeezed that site section together. And in doing that, we've had to think about how those buildings might overshadow each other. So thinking about solar orientation is really key, thinking about the building form and the form factor. all very important. And we kind of took that kind of typical Norwich street section of 14 metres and kind of reinterpreted it as a kind of 21st century street section using solar principles and passivhaus principles. So just 6 very key simple ways of thinking about how you could make a passivhaus project and kind of what makes a difference to others. These are my kind of 6 points, not kind of Passivhaus Trust announced ones. Number 1 is you need really good air tightness, so 0.6 air changes an hour, so you're creating a very airtight box so you're not kind of letting that heat escape through drafts. Number 2 is any heat that you do have in the building, you need to keep it by having really high levels of insulation. So Goldsmith Street, the walls are 600mm thick. Of that, 400mm was insulation. So huge amounts of insulation relative to kind of what you're used to. And that's purely just to keep that heat in. Number 2, which is kind of related to insulation, is triple glazed windows. They're not a big uplift in cost, and actually I think they should be just specified as standard across most projects. I think it's an absolute no-brainer, the number of benefits they have. And partly what goes with that is number 3, which is about where are you getting this free energy from? So a typical 2-bed house on Goldsmith Street, their heating bills are £150 a year, and of that, £90 is the standing charge for gas. So actually it's only using £60 worth of energy a year for a 2-bed house. It's incredibly low. These are genuine figures. It actually works, which always surprises me. But you know, that's what the PHPP model is there for, is it's kind of giving you the data to support the design work that we're doing as a team. But critically, you've still got to get that heat into the house, and you're doing that by basically using the sun and getting that free energy from the sun, which is what number 3 is indicating. So good solar orientation, but at the same time thinking about number 4, which is not getting too much sun, and that's why you need to think about solar shading. So a kind of south-facing window, you're going to cook in the summer, but if you kind of carefully calibrate your shading, that means that you can mitigate that risk of overheating, which is what we've done. Number 5, you've created a really airtight box. I'm sure there's lots of MVHR stands here in the show today, and what that is doing is kind of giving you kind of fresh air rather than having to open the windows and let all the heat escape. So it's kind of very simple. You know, most new build projects will have MVHR these days. And number 6, which is where it gets a little bit more technical, is that you've got to really think about all of the junctions around the envelope, so reducing that thermal bridging, because that is where you're also losing heat. So it's all about retaining the heat that you're getting, hopefully for free from the sun. This is just a very quick overview of the master plan. So you've got a series of east-west terraces. So again, if you think of that sun path, it's going from east to west. So you're getting maximum solar exposure to those windows. If you turn this scheme through 90 degrees, it possibly could work, but you're fighting the sun, which isn't, you know, generally a good idea because it will probably win. And at the end of the day, you're trying to make an efficient scheme. So kind of orientation is absolutely key. So one of the kind of big ideas that we had about the scheme was this idea of a playable landscape. So, you know, I touched on kind of creating communities earlier. So the central garden space you can see running down the middle of the scheme, all of the residents have access from their back doors to that space. And effectively everyone's given away a little bit of their garden for a kind of greater benefit, which is that kind of shared landscape space that runs down the centre of the scheme. The client took a massive risk on actually kind of allowing us to do that, and we were kind of really trying to encourage them that this will be an amazing space, it will work. Kind of ultimately there was always a risk that it could just have been full of fridges and mattresses and just a dumping ground, but you know, residents have really taken that space on, and it's so joyful to see kind of children using that space and people kind of engaging with their neighbours, and it's really become a very simple tool for actually people to get to know each other. So just a very couple of images of the scheme. This is that play space down the middle, connecting into other play spaces. Our house types, very simple, 2-bedroom. So we've orientated most of the habitable rooms so they're south-facing, so kind of thinking about solar orientation, where you're going to want to be. So our kitchen dining spaces have really good south light. The 2 bedrooms on the first floor also south-facing. You'll see we've orientated the living rooms and the bathrooms on the north side, and I'll come on to a picture of that in a minute. So this is our kind of south elevation. So, you know, really thinking about the streetscape, you know, nothing to do with kind of passivhaus. This is about kind of good placemaking. You'll see in this image there's no meter boxes on show, there's no boiler flues, there's no vent covers. All of that has been kind of carefully considered and concealed within the design. So putting that time into thinking about how you create a kind of quality space. This is our north elevation. So The two kind of aluminium covers that you see in the middle there, that's how we've hidden the meter covers on this side of the street. The previous slide I showed you, they were hidden behind the wall. So it's trying to avoid that kind of situation where there's just broken meter covered boxes kind of all over the place, kind of littering the street. Here we've not given the north-entered houses front garden areas. There's just a very thin landscape strip. And that is because we've tried to, in compressing that site section and kind of maximising the use of the site, we've got maximum density out of the scheme. So ultimately, if we'd been following planning guidance and kind of been a little bit looser with our site plan, we'd probably had 26 less units, which ultimately boils down to 26 less homes for kind of families that are really in need. And that's the kind of statistic that I think actually makes kind of those decisions kind of much more acceptable. Another thing, just while I'm on this slide, lots of people say, oh, passive house, you've got to have tiny windows on the north elevation. Ultimately, why would you want a tiny window to your living room? It's bonkers. So this window that you can see on the ground floor here, this is our north-facing living room with a massive window. Now, for those of you who are kind of a bit more kind of tech-savvy, we'll go, well, you've got loads of heat loss going through there. You do have more heat losses going out the north elevation, but it's triple glazed, and ultimately the PHPP model takes all this into account, and it's balanced out within the design. So it might mean that we've got a little bit more insulation within the walls, but ultimately you're creating really kind of good quality rooms that people will be able to use, which I feel is much more important than having a kind of small window. Just another view of our kind of ginnel space down the middle. So as I say, kind of everyone giving away a little bit of their garden space for this kind of fantastic kind of community amenity space, which really is kind of genuinely used, which is kind of really good to see. Oh, it's been cut off. So these are our flat blocks. So this is how we've got the density up on the scheme. So it's 82 homes per hectare. And what you've got here is kind of what we like to think of as big houses. So you've got the scheme is the majority is 2 and 4 bedroom family homes. And then at the end of each of the terraces, we've got 3-storey flat blocks, which have got 1-bed flats in. So they've all got south-facing balconies. So really important to have amenity space, apart from the ground floor one, which has a rear garden. And one of the kind of key ideas that we sold to the client very early on was this idea of no common parts. So your usual approach to the site would be to have a series of flat blocks with a kind of core and a staircase off that. And what Norwich found as a client was that 80% of their issues with their social housing was through common parts. So people doing things that they shouldn't be doing in them, storing bikes, setting fires, taking drugs. And what they said to us as architects was, can you get rid of this problem for us? So we did, and we basically removed the common parts, gave everyone a key to their own front door. What happens behind that front door is completely up to them, and it's given people a real sense of ownership, and I think that's what's been kind of really important for the scheme. And that's been complemented by using lots of different coloured front doors, a very simple, almost free, incredibly cheap way of giving people identity. And there's a story I like to tell of kind of one of the tenants actually picked their house because they were given an option between 2 homes, and they went, I want the red one because I support Manchester United. That person's instantly got a connection with their home, and I think that's what's really special for actually, social housing where people don't actually own the home that they're living in, and hopefully it means they'll take more care of it. So I've just been told I need to move on. So just very quickly, our flats, we've got a ground floor flat, a first floor flat and a second floor flat with this kind of stair that kind of winds up the way through, but importantly everyone's got their own front door. Just the material palette, just something to touch on with Passive House, something that really annoys me. You don't have to use Passive House certified products. As long as you've got a good Passive House designer, they can make sure that the products you're specifying actually work as part of the design. So I'll just kind of move on at that. So this is just one detail I'll very quickly show, so the window detail. So as I said earlier, you've got to really think about those interfaces. Windows are a kind of source of thermal bridging, heat loss, but equally it's how you're getting your kind of free energy from the sun. So this is where probably the most design time went into coming up with a kind of elegant solution to where to place that window in the wall within a timber frame. A lot of people don't realise that there's a timber frame hidden behind the brickwork of this scheme, and just trying to come up with a way of doing Passive House elegantly. And I'm just going to wrap up with a short video that just gives a real kind of good feel for the scheme.
There's a long history of council housing. I mean, it's something that's been happening over 100 years. It's great to see that they're able to do it again, because actually, if you look back at some of the most forward-thinking and innovative housing solutions, they have come from councils. We've seen that the private sector can't deliver sufficient homes that are affordable for people. And I think it's great to see more councils developing. One of the things that we were really concerned about was providing safe places for children to play in the scheme. So there's a number of different areas of landscaping. There are what we're calling ginnels, which are kind of glorified alleyways at the back of people's gardens where small children can play safely. They're actually kind of not publicly accessible, but they open up onto spaces like this. It was really important that children could access play spaces from their houses without crossing roads. It's very rare that a council raises the bar and says, can you do passive house? Normally your aspirations get diluted. But they did ask us, could we do a passive house scheme? And that came from them. The roofs are made of black glossy pantiles, which are a material you see in Norwich a lot because it's quite closely linked with Holland. There's a lot of the Dutch materials that ended up here. So a lot of the buildings you see around have pantiles. I think it's really wonderful to come here when the kids are back from school and see them all playing in the alleyways. It's what we hoped, but we, were slightly maybe nervous about how they'd work, but actually what people tell us is it's been a kind of mechanism for them meeting neighbours, for their kids getting to know each other and making friends. So that's brilliant. It's great to see people living here.
And that's me done. Hope you enjoyed that.
Great. So I think we can agree that's a definite superstar program. I can't believe how many people are here. This is amazing. Thank you very much. Any questions? Do we have a microphone for the audience? Yep, great. And can we take the gentleman in the red coat here and then the gentleman at the front?
Hiya, Phil Bixby, architect and passive house designer. You said at the start of your talk that you need 2 extra consultants, one of which is the passive house designer. A lot of architects are training as passive house designers. Do you see any benefit in there being a separation between those 2 expertises, or is it something you think can combine?
It's a really good question. We've actually come under flack as a practice for people saying, why didn't you do the passive house design yourselves? And I kind of like to, I think where we've done really well as a project is that, we've not tried to do everything. We've specialised in doing the architecture. But what I would say is we've worked really closely with our passive house designer to actually understand the technical constraints that we've had to work to. And I think that's given the project a real strength. I've got a background in working very closely with passive house designers, so I kind of understood the technical issues that they were having to face. And I think ultimately, it'd be like, it's equivalent to saying, why didn't the architecture do the structural engineering? Ultimately it's a consultant discipline, and I think the best projects come from those where everyone's worked together, and I think that's what we've done on this project. So ultimately we could do it as a practice. We are looking to get people trained up, but I still feel that actually our time is best spent focusing on the architecture and actually just working with a design team as we do with other projects.
Great. We might look at that question again when we look at the smaller scale projects. It might be slightly different on a smaller scale project. Gentleman in the front.
Hello, my name's Alan Duncan from the University of Greenwich. I'm wondering which mechanical ventilation heat recovery system you've used. I'm also thinking, in the design stage, what would you have liked to do if you were really pushing it and couldn't? And then what would you like to do now to make it better or fix things that people are saying, if only...
What would we do differently?
Yeah,
no, that's fine. We used Paul Novus and Paul Zender, I think, was the two MVHR systems that we used. I wouldn't know the full ins and outs of that because obviously we didn't specify them. I do know that much though. With respect to what would we do differently, I'll give you two examples. The one would be we wouldn't install gas boilers. So that was obviously a big no-go with kind of decarbonisation, etc. And I think most projects these days you wouldn't kind of default to gas. That was something that was driven by the client 4 years ago when we were obviously developing the project. So I think things have moved on quite a lot since then. We also had lots of problems with services installations on site, so big no to gas. The other thing I would do differently, which is not passive house related, but I think it's a kind of, I'm trying to keep this talk kind of open to other issues, is that the small back gardens, I think we would have probably just done as hard landscaping rather than small areas of lawn. Again, that was a cost issue, but I think actually, that would have made a more practical space for residents as a small terrace area. So, two examples.
Great. And is there one final question, or should we move the gentleman over in the corner? On the left there, just by the speaker.
I'm just wondering about build quality, because obviously Passive House needs a new skill set. Did you have to bring it in, or did you retrain in the area, or did you have problems? Or
No, okay. I probably should have given a mention to the contractor, who was RG Carter, who are a kind of big regional contractor. I think they did an excellent job. In terms of upskilling, the Norwich City Council ran what they called a fabric first framework. So to get onto that, contractors had to demonstrate that they were kind of actually interested in kind of going into passive house design. I think you're going to hear from a contractor shortly. So I think it is about upskilling. The reality is everything from a passive house point of view is, it frustrates me when people think, oh, there's lots of special products on the site, there's all these new skills, new labour. There really isn't. What I like to kind of promote is that actually it's just buildings being built well. And actually having that extra level of care, extra level of quality assurance, because actually the contractor has, everything they do has to be documented. They have to confirm, and record with photographs and submit that they've installed the insulation properly. There's no dodging an air tightness test. It either passes or fails. And I think what's really great from a client's point of view, I think John touched on the performance gap, is that with Passive House, the performance gap is pretty much nothing because you're getting what has been modelled. And I think that's a really important sort of takeaway, is that too often what's being built isn't what was designed. And I think Passive House does close that gap actually genuinely all the way through to being site and being built. So I think as a kind of QA process for potential clients, it's a really good one to look at because one of the things for us to add is that this was done under a JCT traditional contract, which also makes it very unusual. So rather than design and build, which is obviously kind of synonymous within the industry, this is a very large contract to run under as a traditional contract, which we did as a practice as CA. So, we could give the client the confidence that what we drew and specified was actually being delivered on site, and that was a kind of mechanism for trying to ensure quality as well. Hopefully that answers your question.
Thanks very much for that, and I think that's a really good takeaway, not just the client part, but about the actual construction side. It's just building properly, building well and documenting. And Raphael will be talking about how that was done on one of the projects later. If we can just give a quick thank you again to James, that would be, thank you. So for the next presentation, we're going to bring it down a scale and take it down onto an individual property, an individual home. We're going to invite up Jamie Burton from Swan Edwards Architecture. And he's going to be talking to us about Farview Barn, which was the George Clark Building the Dream project. So Jamie, straight over to you.
Thanks, John. As John said, my name's Jamie. I'm from the North Cambridgeshire Flatlands, so please excuse my femboy accent. I'll try and speak slowly and clearly so you can understand me. As John said, this is Farview Barn. It's a certified passive house that was featured on Building the Dream last year. What I'm hoping to do today is give you an overview of the design process and then the end results and how this has benefited the client. So moving on first of all to a bit of context. As you can see, the site's located North Cambridgeshire in rural East Anglia. Its nearest village is 2 miles away, it's the village of Gorefield, and its nearest town of Wisbech is around 7 miles away, and Wisbech being known as the capital of the Fens. The red dot there indicates roughly where that is in the patchwork quilt of the Fendon landscape, and that's kind of what attracted the clients to this site. They relocated and they were very keen for the rural lifestyle. So the site itself is located down an idyllic country lane with the rural buildings around, benefits from the open field views and the big skies that Fendon's famous for. Now the brief for the project was relatively loose. The main driver for the brief, given its remote location, was to secure planning permission. This was combined with delivering a flexible contemporary home, achieving maximum comfort with minimal energy, ensuring the project was future-proofed and ideally preparing to be fossil fuel free, attempting to achieve some level of autonomy, trying to generate an income of some sort, or offer the opportunity for home working, and making sure it was worth more than it cost to build. So this brief kind of perfectly aligned with my values and passions at the time, and seemed to be pretty much in sync with the Passive House standard as well. So as noted, it is quite a remote location. So at the time, the only way that we were aware of achieving this was through paragraph 55 of the NPPF, National Planning Policy Framework, now known as paragraph 79. This is where a building has to be truly outstanding or innovative. At the time, we were acutely aware that there were no certified passive houses in the district of Fenland or surrounding areas, so we set ourselves the target to be the first. After a lot of discussions and negotiations with planning officers, we were successful in convincing them that that was the case. And they noted in their report that the scheme would result in an innovative exemplar project that at this particular point in time is unique to Fenland and would result in significant additional benefits and help to raise the standards of design generally within the district. In doing this, we also acknowledged that UK buildings emit around 25% of carbon emissions associated within the UK, and at the time as well the government targets in 2013, as you can see on screen here. It'd be great to have a chat with everybody to see how you all think we're doing with these. My opinion is not particularly well, which is why, as John mentioned in his opening speech, that the climate emergency has been declared. In my opinion, we're all perfectly placed as architects, designers, engineers, clients and builders to make a significant difference. And I'd encourage all to sign up to the Architects Declare campaign or the other campaigns that are available to us. Now back to Farview Barn. We commenced work on the project in 2013. Using our path to low carbon that was developing at the time. It's a 5-stage approach which starts out from the initial feasibility of the project and test design decisions all the way through to the end product and embodied energy. Now mentioning the embodied energy, it's important to note, I mean this is a simple graph and oversimplifies things, but it's important to note the initial embodied energy of the project is far outweighed during the building's operational energy and carbon emissions. It's not to diminish the importance of embodied energy, rather to ensure that the focus is on reducing life cycle emissions. With that in mind, I consider it's the responsibility on us as designers to design intelligently, ensuring maximised occupant comfort with minimum energy use. Now, that's kind of what we've embodied in our path to low carbon, so we consider that the best way of doing this is combining passive and active design strategies, whereby the building form is optimised and is combined with efficient low energy M&E systems, and we then seek to meet that residual requirement with renewable technology. So step 1 is the initial feasibility and site assessment, where you look at orientation and develop your high-level strategies. Step 2 is where you respond to the opportunities and constraints of the site, combined with the client's brief to deliver optimal building and fabric design. And step 3 is to use efficient M&E systems for the project, ideally low-tech as much as possible. Step 4 is to meet the residual energy needs through renewable technologies. And then step 5 is looking to reduce the embodied energy, which is intrinsically linked to step 2 in achieving the building performance. Now, with regards to Farview Barn, we undertook initial traditional site analysis, looking at the built form of the area, the sight lines and views, boundary conditions, as well as the climatic conditions of the site, so the site orientation, solar exposure, prevailing weather, and etc. Very early on in this process, we decided that the building was going to take an agricultural style in form. It was going to be elongated east-west, as you heard just a few moments ago. So just talking about that, here's the floor plan for the building. So it's been designed around the path of the sun, large south-facing elevation with large south-facing roof, which we'll come on to later. The rooms that require least heat, such as utility rooms, toilets, bathrooms, are located to the north. Rooms that you'd like to benefit from evening sun, such as the snug, are located to the west. So this photograph here perfectly illustrates this. The building itself is single room deep, it's dual aspect, It's flexible space with simple interventions such as the TV block there to create segregation between the spaces. And this photograph here as well demonstrates the solar exposure that we're getting from the south elevation. You can see the floor there is large format tiles which are laid directly onto 150mm thick cement replacement concrete slab on 200mm thick of urethane insulation. Bigger timber frame construction, this was the only opportunity we had to introduce thermal mass into the building, which is very important for absorbing the solar heat during the day and re-emitting it again at times of lower internal temperature. In the background there you can see east-facing glazed screen. We sought to minimise the east and west openings to try and reduce the overheating. This was included, we'll see a little bit later, with some solar shading to allow the clients to move from internal and external spaces and to make the most of the views. Now, as mentioned earlier, overly simplified section demonstrating the principles of cross ventilation through the space, the fact that the building is wrapped in super insulation, and again the three lines there. So you've got the summer solstice, the winter solstice, and the equinox there. And what we sought to do with this project was to optimise the planned depth, so we got maximum winter solar penetration, and also positioned the windows within the depth of the wall build-up to ensure we got minimal summer sun into the building. Now, form factor is a very important point when you're designing a passive house. I've pinched this diagram from Errol Burrell's blog, but this illustrates it perfectly. So the form factor is the relationship between the floor area and the external heat loss area of the building. The most pragmatic, efficient shape being a cube, which is illustrated with a 2.9 figure here. Now, Farview Barn, with its elongated form and vaulted ceilings, which were deliberate choices for the architecture, has a form factor of 2.3, with the optimum figure for a passive house being around 3. Anything above 3, and you really have to start seriously increasing the insulation requirements. So being at 2.3, we're perfectly placed to remain on track to achieve the passive house brief. As mentioned a couple of slides ago, the solar shading, as you can see here, we've minimised the east and west glazing with the exception of this very elaborate gable end glazing here. To offset and combat the overheating risk, we pushed the gable end back into the building, achieving a large overhanging roof. And the first floor balcony you see there, its primary purpose isn't as a balcony, it's to shade the ground floor windows. Our initial design approach to is include these vertical slats across the windows. However, the client wasn't keen on this, so we had to work through with the PHPP software a night cooling strategy and assess the risk of overheating, the outcome of which being the PHPP identified a 4% risk of overheating throughout the year, which is temperatures above 25 degrees centigrade. That was acceptable to the client and also the certifier as warm, with the client agreeing to install external blinds if needed, if it became a problem, which they haven't done to date. Glazing and glazing systems were a very important part of this project. So as you can see, the bottom left slide there, the glazing is wrapped in insulation and all opens inwards. The windows can be opened or encouraged to be opened, but we undertook a heat flux model in the therm calculation software, which was to determine the installation thermal bridge of the windows. The lower the number, the better. And we originally specified a cork face window, which as you can see at the top here. The two photographs are to demonstrate the difference between the windows, which there's virtually none in appearance terms. The cork face windows, when inputted into the PHPP, achieved a heating demand of 10.5 kilowatt hours per metre squared per year, with the passive house standard being 15. During the build of the process, the client opted to go for an aluminium face window, which on the face of it was a simple decision. However, when remodelling this in therm, it had a significant impact on the heating demand of the building. As you can see, it made 3 kilowatt hours per metre squared difference, bringing us up to 13.6. Now, this being our first passive house scheme, we were a little nervous of only having a 1.4 kilowatt hour per square metre buffer between the two. So we upgraded the wall and roof insulation. Initially, we had a warm cell insulation specified, and we upgraded to a platinum bead insulation, which gave us that buffer back in place. As mentioned, air tightness is key with passive houses, as is wind tightness. So wind tightness is as important as air tightness to ensure that heat wicking through the external envelope is reduced. This is where the external conditions of the building can increase the rate of heat loss through the fabric. So a simple form is your friend with both air tightness and wind tightness, and the clients were able to complete the wind tightness layer themselves on site, sealing and taping all the junctions. The air tightness strategy, an important point to note is a lesson we learnt on our own office is that not all OSB is created equal. So we installed 18mm OSB on our office and found that when we did the air test, it failed because the air OSB was leaking. So we learnt a lesson from this, and on this project we used a smart ply with taped joints and all the junctions taped with the windows and floors. The result of this was we achieved an air test of 0.3 with the passivhaus limit being 0.6. So I was very pleased with the strategy that we used on this, and it worked very well. Now, thermal bridging. Thermal bridging was considered from the outset on this project and was very important. So you can see in the top right-hand corner there, the construction of this project was a twin stud timber frame. So 89mm stud internally, 89mm stud externally, with a separating piece between. That's then blown with the platinum bead insulation, as you can see on the top right. An issue with twin stud timber frames is the spacer between is usually a metal spacer, which again results in increased heat loss through the walls. So we work with the timber frame manufacturer and Warm to develop the timber spaces, which is why that photograph at the top left is on here. Going back to the overshading, you can see in the bottom left-hand corner, the overshading was done with an independent steel frame structure. So we didn't puncture the wind-tight layer, we didn't puncture the airtight layer or the insulation layer. So that was completely independent and removed any issues with sealing up or thermal bridges in that location. We were almost thermal bridge free with the construction, with the exception of the 4 columns, which is this central photograph. We worked with a guy called Nick Devlin to do a 3D model of this. And what we did, the solution was to bring the columns inboard as far as we could within the wall construction to ensure that it was wrapped in as much insulation as possible. And we found a product called Armadillo, which, if any of you remember the Dime Bar advert, that was what makes me think of all the time. It's effectively a thin, high compressive strength insulation, which is at the bottom of these columns here, which ensures that when we inputted the thermal bridge into the PHPP, we remained on target. So that was steps 1 and 2 from our process, and what that's done is that's reduced the heating demand of the building through passive measures. So at step 3, we worked with Alan Clark and the Green Building Store to design efficient M&E systems. We adopted a low-tech approach, so we have all your standard things like LED lighting, low-flush toilets, efficient appliances and the like. We have an air source heat pump, which powers the underfloor heating at ground floor and radiators at first floor. Now, the radiators at first floor, according to the client, have never been switched on. They're not needed. We also have rainwater harvesting and the all-important MVHR. Now, this photograph is from our office. It's a Paul Novus system in our office, and the MVHR is very important to ensure that fresh air is continually brought into the building. And what it does is it extracts warm, moist air from the kitchens, bathrooms, utility rooms, passes it through a heat exchanger, and preheats the incoming warm air. Also, very fortunately, as you can see in the bottom left, has filters installed. So the top filter there is the outgoing air, so that's all the dust particles from the office being filtered out, and the bottom one is the incoming air. So it really does take a lot of pollutants and pollen out and creates a healthy environment within the building. The MVHR was also key to our overheating strategy, as it has a summer bypass in place, which means that you can switch off the heat exchanger, and at times of lower temperature outside during the summer months, that'll bring in cooler air throughout the night. So that's steps 1 to 3, and we've really reduced the operational energy of the building. Again, sticking with our low-tech approach, we've sought to meet the residual energy requirements of the building through renewable technologies. So as you can see in the bottom left, we have the air source heat pump, which has a coefficient of performance of 4.5, essentially meaning that for one element of electricity installed, you're getting 4.5 elements of heat out. And we have a 4 kilowatt peak system of solar panels on the roof, and that was all we installed on this project. And so this is the end product. The house is flexible, it's light, it's healthy, it's well ventilated, spacious, makes the most of the fen views, as you can see in the bottom left, and I'm told it's a great place for a house party. The clients are absolutely delighted with the outcome. They've put a lot of blood, sweat and tears into this, which was a true self-build project, and they proudly display their passivhaus plaque up next to their front door. So as well as all this quality of space that they've got, they also had some additional benefits in terms of facts and figures. So the construction cost of both the house and the annex was £500,000. Combined with the land value of £140,000, brings that to a total of £640,000. It's since been valued at £800,000 plus, so we got a big tick in the box there of meeting the client's brief of make it worth more than its cost to build. It was £1,150 per square metre to build the project, and that's because the client did a lot of the work themselves, but as mentioned earlier, that's a very good value passivhaus scheme that they've got there. Now, Now, in terms of the operational energy for the building, the heating, hot water and electricity cost is £985 per year. The main house itself has 5 bedrooms and the annex has 2 bedrooms, so that's for a 7-bedroom house overall, £985 a year. The solar panels on the roof with the feed-in tariff actually generate £1,010 a year, so it costs them nothing to live in this house at all. The annex itself, they rent out on Airbnb, and last year they had an income of £11,000. So this house is paying the client to live there, as well as all the other architectural qualities that it has in place. So they really are living the dream. This project for us has been a real springboard and has allowed me to pursue my dreams of working on low carbon projects for clients and delivering their homes. So these are just a couple of projects we've got on at the moment. The top scheme there is a zero carbon scheme was approved under paragraph 79. The bottom left is a shipping container project which is currently on site at the moment, again to be a certified passive house. The bottom right is my own home, which was a traditional masonry construction, 300mm cavity, and I keep telling the wife it's finished, but I'm not sure she believes me. We also decided to walk the walk and follow in Chris and Frank's footsteps. This is our own certified passive house office, which we completed at the same time. It's a great environment to work in, and it's also a fantastic demonstration for our clients as well. So here are Chris and Frank. I just wanted to put them on here as I owe them a massive gratitude of thanks, and just want to say thank you to them. And that's me done. Thank you very much.
That's great. Thank you very much. So you can see we've had a large-scale social housing brickwork. We've got a smaller, well, pretty big actually, private dwelling, a rural dwelling in timber frame and timber cladding. Any system can be done with Passive House. Other questions for Jamie? No, who would like to have a house like that? The gentleman at the front, if we can start there.
I'm just wondering when it was finished, because I'm amazed that you're getting so much from the photovoltaics. And the other question I was thinking about, have you thought about having it upgraded to a Passive House Plus standard? Thank you.
It was completed in 2018, certified Passive House last year. We haven't thought about having it upgraded, no. We were just very happy we had the Passive House, so yeah.
Great. And can I just have a show of hands? How many people know what Passive House Plus is? How many people know about that? Okay, so that's about a quarter. That's excellent. So the Passive House Plus standard will take you to take account of the renewables side as well as the energy reduction or the energy efficiency side. So Passive House Classic is the standard that just takes you to very low energy demand, particularly for your heating. And then Passive House Plus also takes account of the renewables as well. And then when you're calculating your zero carbon, then Passive House Plus renewables should take you to that zero carbon point. So is there any more questions for Jamie before we let him go, or should we move on to another style of building? James? No? Great. Okay, so thank you very much, Jamie. So we're now going to move on to a different kind of building again. So we're going to have a dense urban site, a little infill project, and we're going to take a different stance. We're going to have a presentation from Ali Shaw from Max Fordham's, who are the engineers, and Raphael Delimata from Bowtie, who were the contractors. And they're going to talk to you more about how to design and build a passive house on a tight site. Seems to be a negotiation about a video, probably. Great. The Max Fordham house. Thank you.
Okay. Hi, everyone. So, Max Fordham House is a new house for Max Fordham. Designed by Beer Architects with Max Fordham himself doing a lot of the kind of philosophical design behind it. Then Raphael here from Bowtie built it. So Max Fordham, he's been in the industry for a long time. He really cares about very low energy buildings and zero carbon and so on. And one of his biggest things that he believes in most deeply is that in this country, if you design a building that needs no heating, then you've done a good job of a sustainable building. Given that space heating is the biggest energy demand of most buildings in the UK, that's fairly true. So A project of his, one of his touchstone projects that he's really proud of, is Casper 2 with Levitt Bernstein Architects from some time ago. In some ways it was Passive House before Passive House. They designed the mechanical ventilation system themselves, and the energy bills when it was built demonstrated that the space heating was covered purely by the occupants, their own metabolism, and the electrical devices they used to go about their day-to-day lives. Domestic hot water was another energy demand on top of that. So this leads to so if you want to design a very low energy building, a building with zero heating demand, then the Passive House process is a robust way and reliable way of doing that with its on-site accreditation and its approach that means that you're likely to actually achieve that goal of no heating. So this leads to Max Fordham's house in 6 Camden Mews. Because the fundamental goal is zero heating, it perhaps has smaller windows than many Passive House buildings, particularly to the south, because Max's main aim is to have no heating on a freezing, overcast day, when solar gain is less beneficial. It's also located within Camden Mews, where there are quite onerous planning constraints. There's various houses built by architects for themselves, such as Ted Cullinan on this mews, and the planning constraints and the site context are quite onerous. So Raphael, do you want to talk a bit about it?
I would like to tell you more about the house envelope and where we started, where we picked it up. So this was a traditional contract. We won the tender. It was looking at the project from the Revit model. It seems to be extremely simple project. We were very excited to start on site, and then we realized it is not that simple. So due to planning constraints, the envelope construction was very difficult. We have many types of the construction on site. So we've got reinforced concrete frame, we got masonry and cavity construction from the neighbor's site. We've got timber construction, I-joist filled with insulation from site sections. Go back to the back of the property. The piling was also required on site. What we can see on the right bottom part is insulation foundation system, which was laid. You can see also a piling reinforcement coming through it. Also, even parts of the pile, the first meter of the pile had to be insulated. Because it was a concrete frame, we assumed the concrete itself will be pretty airtight, and we concentrated our efforts to airtight all the remaining walls. A more traditional method of membrane and tape was used. I think nowadays on a construction like this, we probably will prefer to go with a parch coat, simply because the membranes were not, during the tests, the air was filling up the void between the membrane and the block itself, and causes a bit of a problem. Also, part of the design or planning was to provide what's called blue roofs to attenuate quite a lot of storm water. This particular roof at the back had around 1 meter of soil, and was it a cherry tree? I think we planted cherry trees or some other hazelnut trees. Here we go. Planted on the top of that. Would we do it again? I have to say that it was one of the most challenging elements of the site, coordinating specialist contractors, getting that waterproof, making sure that while you're doing this, your insulation is not filled with water. Having roof over in the very tight mews was another level of complications. Overall, the system was very simple. We had a design from Max Fordham suggesting that all the balconies and roofs have to be waterproof first, and then we build up the levels using gravel, put a special water attenuating boards, and finish this with paving blocks. I think we want to move on to some more exciting things because two previous presenters touch on building envelope and passive house quite a lot. So we want to talk to you about some exciting services.
So I guess one of the unusual things about Max Fordham's house is it has insulated window shutters. So Max was actually inspired by electric car windows, which are airtight at 70 miles an hour and very robust. He wanted to recreate this airtightness with a movable thing that you close at night over your windows and keep heat in. I think it's something he's wanted to design and specify and have built in a building for a couple of decades, and finally, when he was the client, he got to make it happen. So the idea is that at night time, you lose a less heat through the window than you would, and then even on a overcast, freezing day, you get some positive energy benefit through the windows when they're open, and then you close them up again at night time. So I think Max is quite happy that this has actually happened, and they work fairly well at the moment. We started out designing them because me and Max don't really know what we're doing with this sort of thing, with some industrial automation things, but then Raphael came along and simplified it quite a lot.
Two of my friends knew that I'm a Lego fan, so we started this process by spending some company money onto Lego Mindstorm. We're going to play you a video. Obviously, we would love to have Max House to have Lego blocks built in, but this was just a prototype. Since then, we had a few more versions. This both together with Ali decided to go with Arduino, which is an open source controller, which in the future anybody can access and change the programming on it. We then purchased a specialist worm gear motors, but that's basically is the concept that panel covered with ply has an insulation board inside. It's inside aluminium frame, which is fitted within the wall structure. Then panel slides into the wall and comes out of the wall. What this design doesn't show is that all the panels on Max's house have also additional air tightness seals around them. And I think air tightness works around them quite well.
So if you've reduced the space heating demand of a building to as close to zero as you can get it, in a domestic building in the UK, the biggest energy source is then domestic hot water. So that's where more complex technology is focused. So an air source heat pump, a package system, it's installed in a very sunny location, and it's controlled in a simple way to heat 24 hours worth of hot water during the warmest hour of the day when the heat pump's at its most efficient. So it's a simple package system, but designed in a robust way to maximize its benefits. So here it is outside, behind a little wooden enclosure, and it works quite well. And hot water is, well, we'll look at the energy demand in a moment, but it's fairly low. The space heating demand, because the aim is zero heating, but sometimes people go on holiday during the winter time and you need to heat a building up again. And also you might not get there. So the space heating in this case is through an electric heater battery in the mechanical ventilation system, which it's simple and it does what it needs to do. The ventilation system is a Paul Novus, and it's fairly standard in most ways. Although because it is providing the heat into the building, how the air is put into the spaces is fairly important. So it's put in at high velocity to provide good mixing. Max's original intention was this was just a stainless steel tube, but actually this was turned into a 3D printed diffuser.
Yes, I think you all can tell now that we are a bit of a tech geeks. So we wanted to introduce 3D printing to one of our construction sites at all cost. And we had an amazing opportunity that we could print all the ventilation nozzles and adjust the cones or even directions of the cones. In one particular room, the cone is slightly on the curve to basically avoid air hitting the client. I think overall, we're really interested how this could be developed further, because the results of those cones and the aesthetics are quite encouraging.
Yeah, I mean, I think 3D printing, well, air diffusers is a good use for 3D printing because what's on the market is not necessarily what you want and for the air volumes that you want for something. I mean, as a practice at Fordham's, we've got a bit of a history of designing air diffusers in that they're often made out of joinery, which puts a lot of pressure on a joiner to build something where tiny imperfections that you can't see have big impacts in terms of creation of regenerated noise and so on. So I think 3D printed diffusers are quite a good thing to do. Then with lots of buildings that we work on now, towards the beginning we often talk about these super insulated buildings that are very airtight and mechanically ventilated to recover heat. And some clients get nervous about what they're like in the summer and do they get too hot. But we had, the heat wave of last summer, July 2019, it hit all the newspapers, second hottest day on record in the whole of the UK, was measured in Cambridge at 39 degrees, and within Max Fordham's house, it never got above 30, and here the black line is the measured inside air temperatures, and the red line is the measured outside air temperatures at Max's house. So just because you made a very airtight building, it can still work really well in warm weather. In this case, windows that open all the way, and a thermally massive structure for the spaces which are occupied during the day.
So to control all of that, we got the air source heat pumps, we got the lights, additional security, door, entrance system, a few extra safety features for Max as well, because he's an older gentleman, he might require a panic button. We also had those shutters. We decided to go with the locks on, so there are many different types of BMS system on the market, but we like to have one which you can incorporate quite a lot of different products and simple sensors into it. How it worked?
Yeah, so it's been lived in for a year now, so its energy consumption is the middle graph, and if you take away the blue bar, which is space heating, then it would be more or less carbon zero in its own terms in operational use, because the blue bar to the right is what the PV array on the roof does. So it's a lot less than a typical building. Now, it's not all the way there, but is that such a bad thing? Electricity in the UK, it's decarbonising well. If we want to have a zero carbon society, then electrifying all the heat in buildings is perhaps a sensible thing to do. However, if you look at the whole of the UK, the heat demand in the winter is about 5 times what the electrical grid provides at the moment. So simply electrifying everything is not straightforward. However, the marginal increase in electricity for a building which doesn't quite make it all of its own does mean that decarbonising through electrification is fairly more achievable, I'd say. I think the site constraints meant that the amount of roof that you could put PV on is limited. A 2-storey build, this is a 3-storey building. A 2-storey building, you might be able to make it net zero in its own terms, and one where more than a third of the footprint is available as roof space for PV. So within its constraints, it's doing really well, I think.
So we'd like to share a few conclusions from this project with you, and if later technology allows, I want to ask a few questions about how we dealt in terms of quality control on site. So some of our clear conclusion is we understand the windows can be big, but please don't make the whole elevations out of the windows. That really helps in overheating. In terms of our take onto all the 3 2-bedroom housing at the moment, we would try to recommend now air-to-water heat pumps because they're a very simple system, and potentially with the direct electric heating. We always concentrate to deliver envelope as close to passive house as possible, if not passive house. Standalone NVM jar at the moment is a good standard. We used to do that technology. We have no problems achieving excellent results. And yeah, we think that we should electrify all energy consumption.